Welcome to the explainer. If you've ever wondered why something like x equals 5, and then on the very next line, x equals hello, works just fine in Python, when it would cause a complete meltdown in other languages, well, you're in exactly the right place. Today, we're not just going to memorize Python's rules. We are going to build a solid mental model of how Python actually thinks. This is what helps you leap from just knowing syntax to really truly understanding the why behind your code.
And this quote right here, it gets to the very heart of it. It perfectly captures Python's biggest strength and, let's be honest, a huge source of confusion for newcomers. Words like dynamic, interpreted, no-type declarations, these are the things that make Python code feel so clean and simple, but it can also feel a bit like magic. Our goal today is to pull back that curtain and show you what's really happening under the hood. So, here's the plan. We're going to start with the absolute foundation. What happens the second you tell a Python script to run? And from there, every single concept is going to build directly on top of the last one, kind of like stacking Legos. By the time we're done, you'll see the whole picture of how Python thinks.
All right, let's dive in at the very beginning. You've got your code. It's saved in a .py file, but right now it's just text. So how does that text actually tell your computer what to do? What is that journey from your file to a real action inside the machine?
Here's a fundamental problem. You write in Python, but your computer's processor only speaks machine language. The bridge between those two is the Python interpreter. You can think of it like a live translator. It doesn't read your whole script at once. Instead, it reads one line of your code, translates it into instructions the computer understands, and makes sure that command is carried out immediately. Then it moves on to the next line. That line-by-line process is exactly what we mean when we say Python is an interpreted language. Now, for that interpreter to do its job, it needs to understand the structure of your commands. A lot of languages use curly braces or special keywords to group code together. Python does something different, and it's something that forces code to be more readable. It uses white space. That indentation you see isn't just a style choice, it is a hard and fast rule. Indentation tells the interpreter these lines belong together. If you get it wrong, the interpreter gets lost, and your program will fail.
Okay, so we've got the interpreter, and it's reading our code line by line. But for our code to do anything interesting, it has to be able to remember information, right? Like a user's score in a game, or the price of an item. And that brings us to one of the most fundamental ideas, variables and objects.
So how does a program remember stuff? Well, the answer in pretty much every language is variables. But Python's take on variables is pretty unique, and getting this right is the key that unlocks so many other concepts and clears up a ton of beginner confusion. All right, pay close attention, because this slide shows the single biggest mental shift you need to make. We're often taught to think of variables as little boxes that we put data inside. In Python, that's just not how it works. A better way to think about it is that the data itself, say the number 10, is an object that exists somewhere in your computer's memory. The variable isn't the box, it's just a name tag, a label that you stick onto that object. It's a pointer. And this label model perfectly explains why Python is so flexible. When you type x equals 10, Python creates an integer object holding the value 10, and it sticks the label x onto it. Then when you say x equals now a string, you're not putting a string into the x box. No. You're creating a completely new string object, and you're just peeling the x label off of the number 10 and sticking it onto this new string. That's dynamic typing right there. The name can point to anything. So, if variables are just names that point to objects, what kinds of objects can we actually point to? What are the basic building blocks of information that Python gives us to work with? These are the fundamentals in Python's toolbox, and each one is designed for a specific job. You need to work with numbers? You've got integers and floats. Handling text? That's what strings are for. Need to keep a bunch of items in a specific order? You've got lists and tuples. Need to link things together, like a word and its definition? Dictionaries have you covered. And for logic, you have Booleans, true or false. Every one of these is a different type of object, with its own special abilities and rules. And understanding that these types have their own rules helps you avoid really common errors. You see, for a string object, the plus sign means stick these together. But for an integer object, it means add them mathematically. So what happens if you try to plus a string in a number? Python could guess what you want, but that's risky. So instead, it does the safe thing. It raises a type error, basically saying, hey, I don't know how to combine these two different types of objects with a plus sign. The rules don't match.
Okay, so now we have our data stored in different kinds of objects. But right now, our programs are just a straight line of commands. To make them powerful, we need them to be able to make decisions and repeat actions based on the data they're working with. And that's the whole job of control flow. To control the program's flow, Python gives us two main sets of tools. First, for making decisions, we use if, elif, and else. These let us create forks in the road so our program can choose which block of code to run based on some condition. And second, for doing things over and over again, we use for and while loops. These are our tools for automation and efficiency. Let's just walk through exactly how a for loop thinks. So the loop looks at a sequence, in this case, the numbers 0 and 1. First, as you see in step 1, it takes the variable name I and points it to the first item, 0. Then in step 2, it runs all the indented code while I is pointing to 0. After that, step 3, it moves to the next item in the sequence and repoints the label I to the number 1. It runs the code block again. And finally, once it gets to the end of the sequence, the loop just stops. It's a very predictable step-by-step process. So as our programs get bigger, a new problem shows up. We start to notice that we're writing the exact same chunk of code in multiple different places. And that's not just annoying, it's also a recipe for bugs and headaches when you need to make a change. The solution to that problem is the function. We use the def keyword to define a named chunk of code that does one specific thing. Then, anytime we need to perform that task, we can just call the function by its name instead of rewriting all the code. This is what developers mean by keeping your code dry. Don't repeat yourself. It makes everything way more organized and easier to fix. Now, there are two really important rules here. First, because the interpreter reads your file from top to bottom, you have to define a function before you can use it. Simple enough. Second, if you want your function to give a result back to the main program, you have to use the return keyword. This is a super common beginner mistake. If you write a function and forget to return a value, Python won't crash. It'll just automatically give back a special object called none, which basically means nothing. All right, for our last major topic, let's look at how Python groups data together. This is also where we'll introduce a really important, kind of subtle concept called mutability. And you'll see it connects right back to our variables or labels idea. So Python has two main ways to store a sequence of items, lists and tuples. And they look almost the same, but there is one absolutely critical difference between them. A list is mutable, which is a fancy word for changeable. You can add, remove, or change items in a list after you've made it. A tuple, on the other hand, is immutable. It's unchangeable. Once you create a tuple, it's set in stone. You can't alter it. This is super useful when you need to make sure some data never gets changed by accident. This whole idea of mutable explains a classic point of confusion. Let's say you have a list called A. If you use the .sort method, that method actually reaches into the original list object and rearranges it. It mutates it in place. And since it changed the original, it doesn't need to hand anything back, so it returns none. But the sorted function works differently. It leaves your original list completely alone. Instead, it creates a brand new sorted copy and returns that new copy to you. So one modifies the original, and the other creates something new. So let's bring it all home. Here's our complete mental model. At the very base, we have the interpreter, reading our code line by line, paying strict attention to indentation. Inside our code, we use variables, which are just names pointing to objects. What those objects can do depends on their type. We organize our logic into reusable functions, and we group our data into collections, keeping in mind whether they are changeable or not. See how every piece connects? Look, if there's only one thing you walk away with today, let it be this. Variables are names, not containers. They're labels you can move around. Once you really get that, everything else, dynamic typing, how functions work, mutability, it all just clicks into place. You see, building this correct mental model is the real difference between just writing code that somehow works and actually understanding why it works. This foundation lets you read code, debug it, and learn new things way more easily. So now that you have a better idea of how Python actually thinks, what's the first problem you're going to go solve?